break, we just did the basics of solving trig equations. We're going to add a few more steps onto that, and we're going to make the equations a little more complex. So just a couple things of these are more ideas and things we need to think about when solving any equation. The first one being isolate the function on one side of the equation, meaning we need to get, if we have multiple terms with sine or cosine, multiple trig equations, we need to get that on one side of the equal sign. So that's the first thing we need to do here. After we do that, that's when we'll start to solve for the variable, which will include some kind of unit circle stuff. And I will pull out my unit circle once we get there. So go ahead and jot down this equation. And at a quick glance, it looks more complicated than the ones we did before we went on break. And it is. But once we simplify it down and get all the signs on one side of the equation, it's going to look just like what we did previously. So first thing, know that these sine of x's, so 3 sine of x and 5 sine of x, those are like terms, okay? They have the same variable, same exponent, so we can combine those together. So the first thing that I'm going to do is I'm going to subtract this sine of 5 sine of x, so minus 5 sine of x from both sides. That gets rid of the positive 5 sine of x on the right side. And then 3 sine of x minus 5 sine of x gives us negative 2 sine of x. And then we have minus 2 still, and then minus 1. Our task is to essentially get that sine of x all by itself. So the next thing that I'm going to do is add 2. If you want to divide by negative 2, that's fine, but you have to divide everything, so you would end up creating a fraction. So instead, I'm going to add first. So negative 2 sine of x equals positive 1. And then this is negative 2 times sine, so I need to undo multiplying by negative 2 by dividing. So sine of x equals negative 1/2. And once we get here, now this is like what we had done before we went on break. So this is where we'll kind of do that review. So what are we trying to describe here? We are trying to describe the angles where sine equals negative 1/2. And this is where the unit circle comes into play. So on the unit circle, we know that sine of any angle is equal to the y coordinate. So I'm basically looking for, where do I see a y coordinate of negative 1/2? We're going to see it in 2 places. And here's the other thing that we need to consider. Based on the trig functions we're solving, what is the period? And remember, period is just around the unit circle. So how long does it take for the graph to repeat? With sine and cosine, it's 2 pi. So the period here is 2 pi, which tells me I'm going to look on the entire unit circle for these values of negative 1/2. That'll change slightly when we get to tangent. So I'm seeing a negative 1/2 as my y coordinate here at 7 pi over 6, and then again at 11 pi over 6. So within 0 to 2 pi, we have 2 angles at 7 pi over 6, and then again at 11 pi over 6. Now, those are only the 2 angles that are within 0 to 2 pi. But one thing that we talked about before we went on break is that every equation has a graph that models what we're solving for. So I'm going to draw that real quick. If I'm solving sine of x equals negative 1/2, we're basically trying to figure out where does sine of x, so I'm just going to draw a quick sketch of sine, just that little squiggly. Where does it intersect with whatever the right side equals? And the right side being negative 1/2, that's a horizontal line. That's essentially y equals negative 1/2. So that's going to be this horizontal line right here, being y equals negative 1/2. And we can see that it intersects in multiple places. Okay, so there's not just these 2 answers. Okay, these 2 values, 7 pi and 11 pi over 6, are essentially these values here. But then once we travel the full period, we're going to get more answers. And so remember that when we're describing these solutions and when we're describing all the solutions, we have to add on the period and any kind of additional cycles through that period as well. So that's why we're going to say plus 2 pi n. And some of you did a good job remembering that yesterday. Some of us kind of forgot about that. But this way of writing the equations describes all solutions to sine of x equaling negative 1/2. Okay, I'm emphasizing all because we are going to narrow that down here in just a second and be more specific with the solutions we're describing. All right, questions so far? All right, well, I'm going to have you all do this checkpoint 1. Basically the same thing. You're going to work to describe all the solutions, so your answer is going to be in this equation form involving n. Give you a few minutes to do that, and we'll go over it. So describing all the solutions to sine of x, basically we're describing sine of x equals root 3 over 2 after simplifying. So I did subtract the 3 sine of x. That's why it's 2 sine of x, and then divide both sides by 2. So we're trying to find at what angles does sine equal root 3 over 2. That is at pi over 3 and 2 pi over 3 within 0 to 2 pi. And then remember, we need to add on that period and any kind of multiple cycles, so multiple periods after that first cycle. So 2 pi n. And remember that n is an integer, so any whole number, and it can be positive, negative, it can be 0. And we are actually here in just a second going to plug in values of n to get more specific answers to this equation. But these represent every single value or every single angle that we would get root 3 over 2 for. All right, everyone good here? Okay. Another thing we did before we went on break is talked about what happens when the period changes. Now, for those of you that went through the graphing unit, we hopefully can recognize and see that this 3, that's the b value if we were graphing it. And that changes the period. Now, we basically ignore that to start. Whenever we have something that whenever we're not taking just like tangent of x or sine of x or cosine of x, so sine, cosine, tangent of anything other than x, we're going to actually start with the most basic of those equations. So tangent of x, and where does that equal 1? So we're ignoring the 3x to start. The other thing that I want to make note of is we're not describing all the solutions here. It says to solve the equation for where x is between 0 and 2 pi. So we are only going to describe angles that are between 0 and 2 pi, where we're going to get tangent to equal 1. Now, with tangent, the period is pi. And so when we add on the multiple cycles, we're going to add on pi n as opposed to 2 pi n. So tangent of x, where does that equal 1 at what angles? Well, since the period is pi, we are only looking to start or finding an angle within 0 to pi because of that period for tangent being pi. So I'm not even looking in quadrants 3 and 4, just 1 and 2. So at what angle when I take y divided by x am I going to get positive 1? That's here at pi over 4. Root 2 over 2 divided by another root 2 over 2. Well, root 2 divided or over 2 divided by itself is 1. So this is at pi over 4. So the only angle within 0 to pi that makes this true is at pi over 4. But then we're going to get back to that same value at every increment of pi. So as we add in the period. So this describes the solution to just tangent of regular x. And so after we have this solution, we're going to use that equation to come up with our solutions for tangent of 3x. So essentially, I'm going to replace this 3x with the x in our original equation that describes the solutions. So I'm going to take that x, replace it with 3x, and set it equal to pi over 4 plus pi n. And now our task is to get x by itself, which I'm going to do by dividing everything by 3. Making this x equals pi over 4 divided by 3 is pi over 12. And then pi n divided by 3 doesn't simplify, so we'll just leave it as pi n divided by 3. So this equation describes all solutions to tangent of 3x equal to 1. However, we are only wanting to come up with the angles between 0 and 2 pi. So this is where we're going to actually use values of n to come up with this. So our x values within the interval between 0 and 2 pi. Notice how we're including the angle of 0 if it shows up. We are not including the angle of 2 pi, okay, because of it being just less than and that being less than or equal to. To find these values is where we plug in values of n. So I'm going to let n equal 0. So when I plug in n equals 0 to this equation, I'm just adding, or just pi over 12 plus 0, which is just pi over 12. Okay, so nothing more that we need to do for that particular answer. And then we're going to plug in n equals 1. So that makes this pi over 12 plus pi times 1 divided by 3. So plus pi divided by 3. And that needs simplify. So that is pi over 12 plus I need a common denominator. So that would be 4 pi over 12, which makes this 5 pi over 12. So that's another angle between 0 and 2 pi that makes this equation true. And we need to continue to plug in values of n until we get all the angles between 0 and 2 pi, which are actually quite a few more since we're only at 5 pi over 12. So let's do n equals 2. So x equals pi over 12 plus, now this would be 2 pi over 3. So that's pi over 12, get a common denominator. That makes this 8 pi over 12. So this is 9 pi over 12, which reduces down to 3 pi over 4. So we've got 3 so far, and this angle isn't even into pi yet. We need to get all the way to 2 pi. So we're going to have to do this, I think, 3 more times. So let's do n equals 3. And I'm going to skip some of the simplifying steps here and just do them a little bit quicker. So pi over 12 plus 3 pi over 3, which is just plus pi. So that's 12 pi over 12 plus 1 pi over 12 is 13 pi over 12. And then n equals 4. So x equals pi over 12 plus 4 pi over 3. So this is, what, times 4, so 16 pi over 3, so that's 17 pi over 12. And we're still less than 2 pi, right? 17 pi over 12 is not quite 2 pi. So let's do another value of n equals 5, and get x equals pi over 12 plus 5 pi over 3. So that is 21 pi over 12, which I think reduces down to 7 pi over 4. Do I need to plug in n equals 6? Let's see. Let's just see. Let's see. Because we're trying to describe solutions between 0 and 2 pi. So if I take pi over 12, and when n is 6, that makes this 6 pi over 3, which is 2 pi. Is that going to be within the range of being between 0 and 2 pi? So we actually don't need to describe that solution. Even though it's an answer, it's just not an answer within where we're trying to describe the solutions for. Most of the ways we're going to solve the problems, both on Math Excel and the rest of these notes, will be plugging in these values of n. Probably not as much as here, but make sure you read the questions. That's another really important thing. When you get to the Math Excel, read how it wants your answers written, because it will be different for each problem. Okay, questions there. All right, let's have you all do one more. And then we'll do our short break after that. Because the next thing we're going to do is a little bit different. All right. So, remember the first place to start, because this x divided by 2 in the original equation, remember that changes the period. Now, we don't care about that period change to start. We're going to always start with just sine of regular x, and where does it equal that value? So sine of x equals root 3 over 2 at pi over 3, and then plus 2 pi n, and then 2 pi over 3 plus 2 pi n. So you'll always start with that. Then we bring in that x divided by 2, so this is the actual equation for what we're solving. And so I'm taking the equations for how we wrote our previous solutions, and I'm keeping everything the same, except those x's get replaced with x divided by 2. So after I take x divided by 2 and set it equal to pi over 3 plus 2 pi n, then equal to 2 pi over 3 plus 2 pi n, I need to get x by itself, which I can do by multiplying every single thing by 2. And that's what makes this 2 pi over 3 and 4 pi n, because that also gets multiplied by 2. And then 4 pi over 3 plus 4 pi n. So I want to be clear that these equations, and they are equations because they involve n, that second variable, are solutions to sine of x divided by 2, where it equals root 3 over 2. So that describes every angle. We, again, are only describing the angles in between 0 and 2 pi. So I'm going to plug in values of n, so n equals 0. That just gives me 2 pi over 3 and 4 pi over 3. And as soon as I plug in 1, well, we're going to add 4 pi. Adding 4 pi takes us way outside the interval. So in this case, we didn't really need to plug in any values of n besides just 0. Yeah, Blythe, what you got? Because this is x divided by 2, so to undo dividing by 2, you multiply by 2. Yeah. All right, let's take a 5-minute break. We'll come back, and then we got a couple more problems to do. And last set of trig problems we're going to solve are going to be in quadratic form. So we're going to actually have to do some factoring today as well. So we're going to use a method called U substitution. This actually ends up being used quite a bit in when you get to calculus. It allows you to basically take a complicated equation and simplify it down by replacing the complicated part with just another variable. Okay, so an example of these trig equations in quadratic form have like a cosine squared and then just a cosine. So we should be able to recognize that quadratic kind of expression. So if we see something squared, and it's going to involve factoring. So basically, when we're doing this, we recognize the complicated part, or the part that can be replaced to allow this to look like a quadratic that we're used to. So I'm recognizing that I have a cosine squared and then just a cosine. So I'm going to let cosine of x equal u. And what I'm going to do is I'm going to replace every cosine in this equation with the letter u. Now, I want to give a quick reminder. We've seen this cosine squared with some of the identities. Remember that actually means 2 cosine of x squared. That is the same thing as where the squared is written right after the s. So know that those are the same thing, and hopefully that helps us see this substitution a little bit easier. So then plus cosine of x minus 1, and we're looking to see where does that equal 0. So all of these cosine of x's are going to get replaced with the letter u. And you know, let's do some colors. I'll let u be green. So everything in the equation is going to stay the same, except for cosine is going to turn into u. So this is 2u squared. and then plus cosine of x, so plus a u, and then minus 1, and we're looking to see where that equals 0. It has been a little while since we've done factoring, so let's do a quick reminder of how to factor. When we're factoring, we need to find two numbers that add to b, multiply to a times c. So the numbers that add to b here, or b value is 1. A times c is 2 times negative 1, which is negative 2. And the two numbers that meet these conditions are 2 and negative 1. 2 and negative 1. So remember, what these numbers are doing is they're breaking up that middle term, okay, that u. So u has now become 2u minus u, making our equation 2u squared plus 2u minus 1u minus 1. So that u got split up based on our numbers that meet those conditions that add to b and multiply to a times c. And now this is where we're going to do the grouping. So the first two terms get grouped together, and then the last two terms get grouped together. And our task is to take out a greatest common factor in both groupings, and hopefully we get a common factor to show up. So in this first group, I'm recognizing that they both have a 2u, so I'm going to factor that out, making it 2u times u plus 1. In the second factor, the only common factor here is 1 or negative 1. And I know that I want this u plus 1 to show up. And right now, all those signs are the opposite. So I'm going to factor out a negative 1 from those. And then I get that u plus 1 to show up, accomplishing and finding that common factor there. So now we're basically taking out the common factor of u plus 1 and multiplying it by the terms that are left over, being 2u minus 1. And where does that equal 0? So far we haven't done anything with the trig. Okay, we replaced the cosine with u. We factored. Let's now get u by itself, and then we'll re-replace u with cosine of x. So u plus 1 equals 0. 2u minus 1 equals 0. So we get u to equal negative 1, and then 2u equals 1, meaning u equals 1/2. Remember, we're not solving for u. We're replacing for what u equals, which is cosine of x. So I'm now going to take each part here and replace the u with cosine of x. So cosine of x equals negative 1. And then cosine of x equals 1/2. And now we just need to describe the solutions to this, just like what we've been doing. There's just two parts to it now. Okay, so a little bit more. Now, again, read the question. I can't emphasize that enough, especially when you start your Math Excel. We are describing not all the solutions, just the specific angles between 0 and 2 pi. So really just the angles on our unit circle here. So where do I see cosine of x equal to negative 1 at? Well, cosine of x is the x coordinate, and I only see it at pi. Right? That's the only place we're getting negative 1 at. So x equals pi. I can add 2 pi n, but again, that's going to take me out of that interval. So x equals pi is one angle that works and is in between 0 and 2 pi. I don't need to think about the 2 pi n here, because that would automatically take us outside that interval. So then where do I see cosine of x equal to 1/2 at? I see that at pi over 3, and I see it again at 5 pi over 3. And same thing as before. Yes, there's 2 pi n attached to those if we're describing all the solutions, but we're just describing the solutions between 0 and 2 pi. So these three angles are the only angles between 0 and 2 pi that would make this equation true. All right. Any questions there? Did we do the U substitution first semester? No, that's new? Okay. It shows up in, there's another unit that we could have done, and I think I just skipped over it. Okay, I'm going to have you all practice one problem with this U substitution, and then get you going on working after that. Okay, I'll even let you listen to some headphones to that. So I need you to try. Don't wait for me. Let's make sure we did all right here. Um, Again, we're replacing sine of x with u. So the quadratic that we're working to factor is 2u squared minus 3u plus 1. And we're looking to see where does that equal 0. So I'm looking for two numbers that add to negative 3 and multiply to 2. Those numbers are negative 2 and negative 1. I'll get to it. I'm guessing I made a mistake. Let me see if I can find it. So then, when I go to factor, I have 2u squared minus 2u and then minus u plus 1. All good there, right? No mistake yet? Okay, we'll keep going. So then I factor out a 2u, and I get the u minus 1. Then I take out a negative 1, making that u minus 1. I think everything's good there. So then 2u minus 1, u minus 1. I get u to be 1/2 and u to be 1. So then sine of x equals 1/2, sine of x equals 1. I'm not seeing it. The pi over 3. Oh, it's pi over 6. Yeah, let's just write them again. X equals pi over 6. And then x equals 5 pi over 6. Okay. Thank you. I had somebody laugh at me when I was making mistakes before we went on break. Is there somebody in here? No. It's like, I don't laugh at you all when you make mistakes. You can laugh at me. It's okay. All right. Questions here? Okay. I'm going to let you all work on the Math Excel. You might get to some problems that we haven't covered yet. Feel free to try them, especially with the view and example. Let's use this time to be productive. I have no problem with y'all listening to music, but let's not be on our phones. Otherwise, if you get stuck on anything, I'm happy to come help.